Welcome, everyone. The event is now live. Gladys, please take it away.
Welcome, everyone, to today's summit titled AWS Resource Management 101, Cost-Friendly Ways to Optimize Your AWS Environment. Today's summit has been brought to you by the very cool people at Clumio and Lacework. My name is Gladys Rama. I'm the editorial director, and I'll be moderating our first session. This entire summit has been put together by the editorial staff at AWSinsider.net. They worked really hard to bring together some of the best independent experts on this topic, so we really do hope that you enjoy it. Before we get started with the first of these three great sessions, we do have a couple of announcements. First, this event is being recorded and it'll be available to you for future viewing. You'll get an email from us when the replay is available, usually within a few days. Second, each of today's three sessions will be followed by a 5 to 10 minute Q&A. So as soon as a question pops into your head, do throw that question into the Q&A console of your screen there, and we'll try to get to as many as we can after each presentation. Third note, after today's third session, we are giving away a Bose noise canceling headphones, but you have to be present to win. So do make sure to stay on for the entire event to be eligible to win those headphones. And finally, we have a bunch of great resources from our sponsors, Clumio and Lacework, that are available on the console for you right now. So do check those out, download them, ask them some questions. It's because of Clumio and Lacework underwriting this event that we can bring you the summit. So we thank them for sponsoring this summit, supporting the community, and we ask that you do check out those resources when you can so we can bring you more events like this in the future. Now, moving on to the first session of today's summit, this one is titled The Top AWS Resource Hogs You Need to Know About Today, and it's being presented by the great Stephen Smiley. You might recognize him. He's a frequent speaker here with us. Stephen is a certified cloud security professional and AWS ambassador, as well as the consulting director at ScaleSec, where he leads the firm's cloud security advisory and engineering efforts. A former military intelligence officer, Stephen employs both strategic and tactical thinking to help his company's customers accomplish their objectives. And he focuses on architecting secure and reliable systems that allow customers to move swiftly without compromising security. Stephen, I'm so glad you're here with us. Take it away.
Hey, thank you so much for having me back today. This is an interesting topic, right? We're talking about resource management, costs, and all the fun stuff. This is something that I deal with kind of on a day-to-day basis, and I'm happy to share with our attendees today what I've learned and kind of the way that I look at this and the way that I have found a lot of optimization opportunities, which is something that I feel proud that I have done, right? I do this both deliberately, right? Like specifically going through a new environment, looking for ways to optimize, but also kind of on a constant basis, which is one of the themes that we're gonna see today, is that this is something that we should probably be doing continuously, like every time we touch things. So on a regular basis, like my focus tends to be more around security. I help customers assess their cloud security, like the technical things, but also their program aspects and compliance programs. I help people set up new landing zones. So if you happen to be a customer that's looking to start a new cloud environment and you're here because you're trying to get ideas about how to do that well, let me know your questions. I'd be happy to help you. I set up a lot of what we call kind of landing zones for new environments to try to get these things right from the beginning. And then I also do a lot of platform engineering. So like helping people set up, secure, reliable foundations that they can use to deploy. And so, I'm really passionate about all of those things. So let me know what your questions are. At a high level, this is the way that I think about cloud financial management. And so you'll see this as my broad framework today. So at the top, we think about governance, right? So we think about the cost optimization function in your organization. And we'll remember that this needs to be a partnership between finance and technology, right? It's not just technology, but it also can't be just, finance or management without an understanding of the underlying, technical trade-offs. And so that's going to look a little bit different in every organization. I'd be happy to help you talk about how that might fit into your organization. A big company might have an entire team dedicated to cost optimization, where they're constantly going through workloads, working with the teams that manage those, and trying to identify ways to improve. Smaller companies probably don't need to do that and just wouldn't dedicate those resources. And they would put that responsibility on directly on the teams. But somewhere in your organization, you should be thinking about this and how that's going to work. One of the other things that a governance function should be doing is identifying cost attribution categories. So like, how are we going to categorize these costs, right? There's a feature in AWS that gives us the ability to group things by account or services and split these up in a variety of ways. I've got a screenshot here of what that looks like. And if you don't have these, it's really difficult to know where you're drawing your lines. And so you'll get costs that don't really belong to anybody, and that's where we run into issues. The other thing that is important is, once you've got those cost categories, is to set up budgets, right, and forecasts. So you say, okay, I know this category, I know how much it's costing me today. Well, how much am I willing to spend on this? When would I want an alert? And would I know if this changed drastically? The nature of cloud as a model is that these costs are variable, right? And so we have to know, we have to let them flex up, let them flex down, hopefully, but keep an eye on it and know if that flex is too much, right? And so we need to get those alerts. So I really want to hammer in that, like, governance is a critical piece to successful cloud financial management. And although most of what we talk about today is going to be around how to optimize your actual workloads, that's the smaller picture relative to broad governance. The other thing that we're going to see is that at the platform level, we need to structure our accounts so that we can have that visibility, because those are going to be the broadest categories that we have, and that will give us the ability to apply policies to accounts. And if we don't have those structured well early on, it's going to be very difficult to figure out how to apply policies to different environments. And we're going to look a little bit more closely at that in a minute. And then I also think that you should be thinking about the operations cadence for your cloud financial management. So, we've got governance, we've got, some platform things in place, but how often are we going to review our workloads, right? Is this something that we look at once a year, or is this something that we look at monthly, right? Or somewhere in between? And there should be some cadence, right? Even if it's slow, we should know when we want to come back and take a look at this. We also just broadly want our organization to have a cost-aware culture. And one of the ways that we do this is by having an operational cadence that asks, is this the right amount of costs, right? Like, can we reduce this? What would be the trade-offs? And by doing that, the next time somebody decides to make a change, they're going to think about those costs and understand those a bit more. So I really do think that governance and platform and operations are crucial to successful cloud financial management. But at the end of the day, the changes are going to come from your architecture and the way that you optimize those. And so that is what we're going to focus on mostly today, about how you can actually do that. So let's get into it. One of the first things that I really highly recommend is that you limit access to a bunch of actions in AWS that are very like rarely needed and have big impacts. So, the vast majority of organizations out there have somebody who's an admin, right? And they've got full access. And as much as we try to limit that, somebody's probably got it out there. And one of the things that we should do is limit access to purchasing commitments, for example, because probably the person who is the admin is not doing that on a regular basis. And if they do perform that action, it's going to have a big impact. So we want to have some sort of process by which we block that access, and then we can, lift that block, perform the action, and then reapply the block so that it occurs under control. So I've put on the screen here the actions that I try to pay attention to. So for example, accepting agreements in the marketplace or subscribing to things, that can be an annual commitment, right? That can involve a third-party purchase. That's probably something that an IT admin is not going to do unilaterally, right? Also, savings plan, EC2 reserved instances, RDS reserved instances. These are things that can cost hundreds of thousands, if not more, money just in a single click. And actually, very recently, AWS introduced the ability to refund a savings plan if it was accidentally purchased, but I wouldn't rely on that, So control these actions, make sure that somebody can't spend $500,000 without some process. So the other actions involve like DynamoDB, purchased reserved capacity, Redshift, purchase a reserved node. So these work very similar to reserved instances, but most of the time people just focus on reserved instances, and we should think about the broader set of these actions. And then one of the new ones from the relatively new Amazon Bedrock service for AI inference is creating provisioned model throughput. So that's kind of like a reservation, but it's a commitment of spend to use the Bedrock service. So we should carefully control these actions. The other actions I think that you should consider that aren't necessarily like super expensive are things that have long-term impacts. So they could be very, very expensive if not controlled. So for example, the S3 service has the ability to lock objects for legal holds or just generally object retention. It can't be deleted, or there's an action to bypass a governance retention. And then relatedly, Glacier, which is now kind of rolled up under S3, but that's their long-term cold storage service, has a vault lock. So you can lock these objects away, and they cannot be deleted. So that whole time that you're committing to storing those objects, you're also committing to pay for the storage of those objects. So this is another thing that I think is really important to control purchasing of. Shield is a good service for protection against distributed denial of service attacks, but it does have a minimum cost that's in the tens of thousands. And so creating a subscription to Shield Advanced is something that you don't want to have available, without management. Creating a private certificate authority through the AWS, now it's called Private CA service, is another thing. I think it costs about $400 a month as a base price. And that's just something that you don't want to have somebody accidentally purchase and commit to. And then also purchasing domains, registering domains and transferring domains out of Route 53. These are things that just have long-term impacts, right? If you transferred domain ownership to something else and that was done, maliciously or accidentally, that could have a big impact. Or, registering a domain, these have long-term impacts. What if you accidentally do that in the wrong AWS account, for example, and you wanted to manage it in a different account? So these are things you really want to have careful plans for every time you do them. So how do we apply these controls? Well, we do them with AWS service control policies through the AWS organizations service. And these policies can be applied at either an account level or at an organizational unit level. But importantly, they cannot be applied to the entire account or the entire organization. So more specifically, there is always a account at the top. Used to be called master. Now it goes by the name of management. And on this diagram, it's shown as the root. I guess that's the root OU. But the management account cannot have a policy applied. So that's one of the reasons to kind of avoid putting anything in the management account and strictly controlling its access to anybody. And then doing everything else in one of these accounts that you can apply a policy to. So for most of your organization, you can just have all of those actions restricted. And then in some of the other accounts, you may have even more strict policies. So for example, limiting the use of regions, right? Saying for all of our production accounts, we are only going to use these 2 regions, right? And that way you don't have any surprise costs when something pops up in Ireland and you weren't expecting anything in Ireland, right? Or you may also say that we're going to limit the use of services. We're going to say, in production, we don't see any expected use of SageMaker. And so we don't want to see any costs from that. And the best way is to just completely prevent that from being spun up in those accounts. And as you can see, this relies on us having a clean organizational structure from the start. So this is something that I work with customers to get set up well, because this doesn't tend to happen organically as your organization just grows, little by little. And then it's very difficult to move resources later. Okay, so we've got our governance, we've got our platform, and we've talked about operations. Let's actually get into the meat of this and say, how do we optimize workloads for costs, right? Well, the first thing I want to say is that optimize does not always mean reduce, right? We always have to consider the trade-offs of costs against our other system characteristics, right? So how much staff time, is this worth, right? Like if I choose something that's lower cost, but it's going to take higher effort, is that the trade-off that I want to make, right? How about security, right? If I avoid turning on a security service and using it effectively, am I really saving costs? Because what would an incident cost us, both financially or reputationally? And wouldn't I rather pay a little bit more and have that done correctly? Probably, right? There's also always trade-offs with availability and performance. So for example, if I'm going to have a database and I want to make sure that it's highly available, I'm probably going to pick a multi-AZ database that has some automatic failover between the different availability zones. That's going to cost a little bit more. That's probably, in a production use case, a good trade-off, right? I don't necessarily need to make that in a pre-production environment, however. And depending on your workload, you might say that's not a huge deal. The downtime wouldn't cost us that much, and we would just ride it out. So that's something that you can evaluate for your situation. And then the other common trade-off is with performance, right? So, people tend to over allocate resources so that they don't run into performance issues, especially when it comes to something like EC2 instances. Why would you pick a smaller compute instance over a bigger one and run into issues? But you need to figure out what the right balance is there. And there are some tools that we can talk about to help you find the right balance between that. But going too far and reducing the performance might impact your customer experience, right? And we know that has big impacts on your customer retention and their likelihood to purchase something from you, or whatever it is in your situation. But consider that trade-off, because just reducing costs is not always the right answer. So one situation in particular is that here's a security situation that cost the Optus company $140 million when they had customer data exfiltrated out of their Google Cloud environment, where they had public unauthenticated API endpoints that they were not aware of. The attacker identified this, and they were able to figure out that customer identifiers were sequential. And they accessed the API through varying IP addresses to try to pull out all this customer data. They came and asked for $1 million to stop the leak, but ultimately Optus told everybody that it cost them $140 million in all their legal fees and threat incident response. Customer, they had to compensate their customers, so a bunch of things. And it's like, we need to consider these costs as real costs, right? So $140 million is going to way outweigh the cost of the security services that we might use to prevent that attack, right? And so we can talk a lot about the defenses that may have prevented this attack, but in particular, a threat detection service that would have alerted on the suspicious access patterns would have been really useful, right? And that would have been able to stop this before a lot of the customer data was exfiltrated. And so that's something in AWS that's like Amazon Guard Duty would have been able to detect the patterns like this. And that may have saved them a ton of money. So we'll consider those trade-offs. So as we go to look at our workloads, this is kind of the structure that I'm thinking about as I look at a particular thing. So one thing is that I really think it's important to look at workloads with whatever boundary makes sense for them. So I use this term workload, and it's difficult to understand, like, well, where does the workload start? Where does it end? What is an application, right? And that's going to depend on your situation. But in general, I think it's more important to figure out what that boundary is, rather than just look at your services across your entire organization, because they each have their own context, as we've discussed before. So one of the first things that I'm going to look for is, like, what regions are in use. Depending on your workload or your situation, you might have 2 regions, you might have 5, you might only be using 1, but that's honestly actually pretty rare. Like the vast majority of the time, people have put things in at least 2 regions. And so you got to make sure that you're looking at those. Otherwise, it can really feel like a blind spot if you're not checking that. And then within that region, what services are we using, right? So I'm going to go to my Cost Explorer, and I'm going to filter by region and group by service. And then I'm going to get a graph that looks something like what we have on the screen here. It's like, oh, hey, I'm actually using a lot of EC2 instances here, and those just popped up in October. Like, what changed, right? So this is going to give us the broad story of our cost usage over time and the specific services. And then as I'm looking at these, I'm going to be thinking about these primary pitfalls and the potential responses that I have to them, right? So I'm going to be looking for resources that may be unnecessary or forgotten, and I'm going to just try to review those and remove them, right? One of the ones that I see a lot here is like Amazon Workspaces, which is a virtual desktop service. People will spin that up because they have a need to do something in a virtual desktop, but then they forget about it and they don't realize that we're paying monthly, or hourly for that virtual desktop. And if I need it again, I can always spin it back up. But I don't need to pay for it for the next 3 years while nobody pays attention to it. So find those unnecessary or forgotten resources, remove them, and save money. Easy. The next one is thinking about things that are probably too big or are really inflexible. And this is where we get this concept of right-sizing services, right-sizing an instance, something like that, and thinking about how we can find the right size or hopefully set it to auto scale to some degree, which is going to depend on the service itself. And we're going to talk about these things by service later. And then the last one is like, is this just an inefficient use of this service? Can I re-architect this? That is going to involve more work, right? It's going to involve a deeper understanding of what that workload is trying to do, why it was designed that way in the first place, which, you know, maybe the situation's changed and you've learned some new things and you can re-architect it. This is where there is a lot of opportunity for improvement, but it's also the biggest effort. So focusing on those first two, right, unnecessary things and inflexible or, you know, too big things is where you're going to get like 80% of your kind of quick wins. As you do use the Cost Explorer to do this initial research, I recommend that you go and click the little wheel and look for the extra preferences and see what else you can see, because there's extra information in here that can be really helpful. So for example, the API operation, purchase options and platforms, these things can give you a lot more information than just the region and service. So check that out. As we talk about re-architecting things, one of the words that comes up a lot here is serverless, and it's a bit contentious because some people think that serverless is you know, a lie and maybe a pitfall where, you know, nothing's really serverless. There's servers under there, and it's not going to save you any money. Just buy a server. And other people are going to say serverless is really the best possible way to get efficient service. And the answer is that, like, it's obviously on a spectrum and there's answers in between. And it's generally going to involve a trade-off between operations, right? So EC2 instances can be, you know, considered here on the left side of this spectrum with more operations involved. I have to configure patching for them. I have to, you know, monitor their status, and I might need to SSH into them to debug something that's going on. You know, so there's a lot more to it. And then on the other side, there's Lambda functions that I don't have to do almost anything for, give me almost no operations. But if I'm running that Lambda function all day, it is going to cost more on a, you know, on a, you know, minute by minute basis than paying for an EC2 instance. So that's where Lambda is not suited for the same kinds of things. And that's where an architect is going to be thinking about these different trade-offs. And then, you know, somewhere in between is there something like ECS Fargate, where I don't have to manage the underlying instance. I can run a containerized application on an event-driven basis as a, you know, as a task. I can run it scheduled as a task, or I can run it as a always-on service, and it's going to cost a little bit more, but I don't have to worry about the underlying instance at all. So this is something that continues to evolve, but think about that spectrum and try not to be too one-sided about this answer as you're looking to architect things. And, you know, the big promise of serverless is not just operations, but generally avoiding your need to do capacity planning. So we can see here on these graphs that we would like to avoid paying for idle compute in particular, and let it scale to match our utilization. So think about that in the context of your services and see where it applies to you. Okay, so let's get into some specific AWS services that I think you should be reviewing for cost savings. S3 is one of the big ones where you should be taking a look at this on a regular basis. S3 has a storage lens service that will give you some org-wide visibility and analysis. My favorite ways to look at this are by storage class and taking a look at buckets that have like no retrieval. And so we can do that. I have a screenshot here where I'm saying, one of the axes is retrieval rate. If I have a bucket that has no retrieval, I really want to make sure that it is using a storage class that matches that retrieval. I don't want to be paying for the standard storage if I'm never actually retrieving those objects. And so we can be looking at reducing that. And I'm going to talk here in a second about specific storage classes. We also want to make sure that on every bucket that we have some sort of life cycle policy, hopefully to delete that data at some point. I mean, even your most sensitive data that may even have a compliance requirement to be, saved for 7 years or 10 years or something, that should still have a lifecycle policy that says delete this after 7 years, right? And after 3 years, transition it to a lower cost storage class. So everything should have a lifecycle policy of some sort. If you don't have one, it's an opportunity to go and think about that and apply it. This is also coincidentally the best way to delete data if you find data that is stale, that you no longer want. You don't want to go and run a script that tries to delete every object individually. You actually will pay for that API call, and it will be very difficult to make it happen. Whereas just setting a lifecycle policy to expire all of it will be cheaper and easier, and let Amazon handle that for you. So there's a really valuable tip if that's not something you're already familiar with. Okay, so I get this question a lot. What storage class in S3 should I be using? And the answer is like fairly straightforward. If you're going to access this data more than once a month, just leave it in the standard storage. But if you're not, look at one of the other ones. So if you're going to access this once a month, it really can go in standard infrequent. You're going to get some cost savings and not notice any issues in performance. If you're accessing this like once a quarter, Glacier Instant Retrieval works very well. And Glacier Instant Retrieval is actually a relatively new storage class that does not involve the step of transitioning it first, which is what we used to have to do in Glacier, and what we still have to do if we use Glacier Flexible Retrieval. I strongly recommend that you avoid using the Flexible Retrieval storage class. It's very difficult to retrieve that when you do need it. So in security, I have to do this sometimes. People are like, I need logs from this period of time. And when you need those now, right? Like you don't actually have that much time to go and pull that up because you're doing an incident response and you need to evaluate those logs, right? With flexible retrieval, you have to make an API call that says, I want to restore this. And then you have to like wait for that to be completed. And it's not that long, but it's longer than you need. And so just using Glacier Instant Retrieval saves you a lot of heartache, and it's still a lot cheaper than standard. And then of course, if you're not sure yet, please just use the intelligent tiering storage class, because it works really well. It uses these same storage classes. It calls them slightly different names. It calls them like frequent, infrequent, and archive. But it will work very well. It'll figure this out, and then you don't have to worry about it. So use that as a base thing if you're not sure, which is, most of the time you're like, I don't know when I'm going to access this. So just use intelligent tiering. The other really quick win in AWS is CloudWatch logs. The default for the log groups is to just never expire them, and just adds up, right? Especially over a year of something that you run that function once or whatever, and then it just sits there that whole time. So just really make sure that you set a retention period on every log group you ever create, and every once in a while go through and take a look at these log groups and just filter them by their, or sort them by their retention. And if something has never expire, set a retention period, or just delete those logs. And these can get really expensive. It is actually not that uncommon that I see environments where the cost of the logs match the cost of everything else, which really should not be the case. The other tip is to use log levels in your applications. So, I mean, this is pretty common, but your logging library for your application almost definitely supports this, right? Where you can say, set this to a debug level, or info, warning, error, critical, something like that. In production, I want to make sure that I see all the errors and critical logs. I need to see those, and I might want to keep them longer so that I can look back and figure out when this error first occurred or something like that. But I definitely do not need all my debug or info logs in production. But those are super helpful for debugging issues in pre-production. But I probably don't need to retain them for as long because I'm making changes more frequently, right? So use these log levels, set them. You can use the same application code in multiple environments, but they log to different levels, and I can set the retention periods appropriately, and boom, I have optimized the cost here, and I have provided the best developer experience I can without a trade-off in my production troubleshooting. So this is really important. I think this is super often overlooked, and you should take a look at it. The other thing to be aware of is that AWS is now charging for IP version 4 addresses. It makes sense. Those addresses are scarce, and so it's probably a good. They're disincentivizing excess usage, and it's not that much. I mean, it's like 0.005 IP per hour, but this could add up if you're using a lot of them, and a lot of people are, because you used to be able to get a free one per EC2 instance. So go check out the IP address manager that AWS has available. I've got a screenshot here. It'll help you see where you're using public IPs, and a lot of times you don't need them. When I set up networking architecture, I set up almost all of my services in private subnets, and they can talk to the internet over a NAT gateway. The NAT gateway has a public IP address, but that's like one per availability zone. And then there's maybe like a couple other things that you might need publicly, but you shouldn't have huge swaths of public IP addresses. If you do, it's probably a sign that we can optimize our network architecture. That's something I'd be happy to help you work through if that's something you're running into. So specifically, when we're looking at EC2 instances, here are the big bang questions that I look at. So how much are we taking advantage of Spot instances, right? People talk about Spot, but they're not used that much. So go take a look. And the way to do this is by looking at the usage type. And it's a little weird because it says box, which means on-demand pricing, or Spot, okay? So once you do that, you can group it by the purchase option, and you'll see your Spot instance usage. I mean, if you're not using them, take a look. There are some trade-offs. You have to make sure that this workload could be interrupted without an issue. But it makes a lot of sense to try to make use of this and save some money, especially in like pre-production, where you might have auto-scaling groups, and it's not a big deal if something is replaced or taken out. You should also be looking at your instance types, right? So go in and filter by EC2 instances, group it by instance type, and think about this. The pattern that happens so much is that people pick an instance type just when they're prototyping something just to make it work, and then they never come back and revisit that. It's a good opportunity to revisit that and figure out what is the right price performance ratio that I want. And watch out for these like rarely needed types. I have a few examples on screen, but that kind of changes all the time as new instance types come out. So just watch out for those because some of them can be like ridiculously expensive and you don't need them. The other thing, and this is one of the ones that like I find a lot of savings with, is burstable instances. So burstable instances can be great because they can have a low utilization a lot of the time and then burst up when something new happens and then they go back down. The problem is if you are consistently bursting beyond the baseline, you actually end up paying extra. So it can be cheaper to just use a bigger instance than to be consistently bursting beyond the baseline. The way to find that is by looking in Cost Explorer under EC2 Other with usage type, and you'll see how often you're bursting beyond the baseline, and you can optimize that right there. That is like very little known, and I think one of my better tips for cost optimization. Steal it from me, please. The EC2 Compute Optimizer feature has gotten a lot better over the last year or two. It used to be, not so great, but it keeps taking into consideration more characteristics of your instances. And it can be really helpful, not just for picking the size, but also figuring out what the right instance family is. Like if you want it to be compute optimized or memory optimized or something like that. And I often find that the workload is just performing differently than people expected. And so switching to a different family makes a lot of sense. And then also you should really, really be looking for adoption of the AWS Graviton feature, where you can get like 40% better price performance with those G instance suffixes. Those can just really save costs and improve performance. There's almost no trade-off there. You just need to spot it. Especially in non-production environments, I recommend taking a look at Instance Scheduler. If you don't need that running all night, running it for 8 hours a day as opposed to 24 hours a day, hey, that's a third, right? So I'm taking a look at that. You should also be looking at using auto scaling and spot instances. I know that sounds obvious, but if you're not looking at that, you're probably not doing that, and you can get 2 to 3 times savings. And there's actually a new allocation strategy that says like price capacity optimized, that if you don't have another opinion, I would say that should be your default for how you auto scale things, because it takes into consideration the price and the capacity, and it tries to balance that for you. It does a very good job. And then the other thing is, like, if you're actually looking at EC2 instances, you should be thinking, like, does this belong as an EC2 instance, or should this be refactored? Is this just a little script that runs every once in a while? Can I just run this as a Lambda function? Can I run this as a Fargate task? Because it's maybe bigger than a Lambda function. It's going to run for 15 minutes or something, and it's not great for Lambda. So should I run this as a Fargate task, or should I even just run this as an SSM runbook, right? So Systems Manager has the ability to run a PowerShell script, for example. This is something that people do a lot on EC2 instances, where they just have a bunch of scheduled tasks. Well, Systems Manager can do that, and it costs you almost nothing. So think about, what is this EC2 instance for, and can I get rid of it? One of the other ones is like Bastion hosts. I mean, if you're in AWS, almost nobody needs a Bastion host anymore, because I can use Systems Manager to connect to something, and I didn't publicly expose an RDP or an SSH port. So just drop that EC2 instance, and I have improved both my security and my cost. So what is this EC2 instance doing? Do I really need it? It's just not a question people ask enough. You should be asking it. Okay, EC2 Other, this is another one that's really big. So looking at these costs, what are they? The big ones to look out for are interzone data transfer. That's where, data is going from one AZ to the other's AZ, and it's probably just a mistake in your network design. Idle NAT gateways, a lot of VPCs are spun up just assuming that you need extra NAT gateways, and you can avoid them. You should also be looking for unattached stranded like block store disks. This happens a lot. You launch an instance, you kill the instance, but the disk stays around, right? AWS doesn't know if you want to keep that in that volume. So just delete it. And then when you are spinning up a new thing, you really want to default to really small volumes. It's always easy to increase disk space. It has no interruption whatsoever, but it's basically impractical to reduce the size. That's not something that AWS can do on your behalf. You have to create a new one, copy the data over, move it. It's not great. So look for those costs, see where you can find them. I'm happy to dig into any of these more deeply if somebody would like. So just let me know in the questions. Lambda is one that's usually not a major resource hog, but if it is a major focus for you, you can look at the Lambda power tuning tool, which will help you find this crossover point between your invocation time and your invocation cost. So that's something that you can consider if it applies to you. Lambda is not right for every workload, so there are ways to optimize this. That's going to be dependent on your situation. I'd be happy to help you dig into this. I love Lambda, but it just has to kind of be done just right, where you're, avoiding spinning up new database connections every time, or caching. You have to make sure you're caching your static assets. You're not pulling those in every time, things like that. And so you'll get this amazing graph that'll show you, what is the fastest execution time, what's the lowest cost, and you can try to find the right balance of your Lambda size. I also recommend taking a look at your ECS instances. Fargate Spot is something that's used very rarely. You don't have to only put things in Fargate Spot. It can be a secondary, provider strategy. But Fargate tends to be containerized workloads that are good at being interrupted. And so this is a good fit. So take a look at that. Let me know if you have questions about, ECS things, but it's pretty much kind of the same as the rest of the EC2. If you're a heavy user of EKS, one of the tricks here is that you don't have great visibility into what's going on inside your cluster, but KubeCost is this project that's attempting to, give you a better cost allocation of that. So if you have a good use of EKS, take a look. That could be really helpful. And then Carpenter as well is a replacement for the standard Kubernetes cluster autoscaler that, for the most part, people report better autoscaling performance as well as cost optimization. So definitely take a look at that. RDS. One of the best ways to save costs with RDS is to adopt the AWS Graviton. It has virtually no effort. It just works. And people just don't use it because they set up their RDS instances before that. So take a look. And we already talked about some of these other things like using multi-AZ in production, but not non-prod. And Aurora serverless, especially the second version, is still emerging and it keeps getting better. It's not exactly the best money saver out there because it doesn't scale to zero. But my big tip is that you can mix a serverless read replica in the same cluster as your non-serverless instance. And so that can scale up as a read replica if you suddenly get a bunch of extra reads. And so that's available, but it won't cost you a ton of extra. And then you can look for performance insights. This is one where AWS has really helped you figure out what queries are causing major performance issues. And if you can figure that out, you might be able to use a smaller database and save a bunch of money. So I know I've gone through a bunch of that stuff super fast. I would love to answer any of the questions that you have. And just remember, it really comes down to this framework of governance and platform and operations, and then, careful look at optimizing your workload architecture. So I know I threw a lot at you. I would love to answer your questions now. I will hand it over.
Perfect. We do have a bunch of questions, Stephen. So first of all, thanks for that great presentation. And a reminder, everyone, that Stephen's presentation will be available for you to view after. So there's a lot of information to digest there. You will be able to look at these slides again, so don't you worry. All right, questions. First one from, I hope I'm pronouncing this correctly, Naidu, who asked, when it comes to optimizing the costs associated with AWS infrastructure and solution mix, do you have a list of top 5 or top 10 taxing items that need to be looked at?
Yeah, so basically that, what I tried to go through here are the top things that I think are most important. So most people are going to focus on EC2 instances, especially if that's 80% of your cost. And people are going to say, buy a reserved instance or savings plan, and that's fine. But I really do think that some of the quick wins are getting rid of a bunch of stale S3 objects, getting rid of old CloudWatch logs, finding stale NAT gateways or just unnecessary ones, and scaling down instances to fit, or even just getting rid of them because they could be run as a Lambda function, something like that. So I have worked with customers specifically where I just sit down with them for a month and try to come up with these solutions, and this is what I've come up with as my major hit list of things. And if you would like me to do that, I'd be happy to help you look at your situation. Yeah.
Perfect. Here's one from Tim. We're looking to start a new migration to AWS. When it comes to cost management or minimizing costs, would it be better to migrate everything at once or piecemeal?
Oh yeah, that's a good question. So my big thing is you don't need to migrate everything at once, but what you do decide to migrate, you want to make sure that you're not straddling the fence for too long, right? You want to get it over and get it optimized and then go start the next one, right? So that's a perfect opportunity for you to think about how you might refactor the application to take advantage of cloud services, or especially rethink your security strategy around that. What is my threat model? Has it changed? How am I going to secure this? So that's a good thing to do on kind of a workload by workload basis, and not necessarily everything all at once.
Great. Here's one from John. How can I check if all resources are tagged so that I can split them in Cost Explorer? I still cannot figure out if all of my resources are tagged because I get untagged resources in Cost Explorer.
Yeah, so there is a feature of a tag policy in AWS organizations you may be aware of, and it can be done in 2 ways, right? So you can try to have it enforce them, which means it'll actually block creation of a resource if it doesn't have the corresponding tags. That can be kind of aggressive, but if you've got a solid strategy, that's something you can consider. You can also put the tag policy in just a mode where it'll just help you list all EC2 instances by tag, and you can say which ones don't have this tag, and then you can actually apply them right there. So that is super useful. Of course, I do recommend that you use infrastructure as code, right? Something like CloudFormation to manage your resources. So that's really where you should be applying tags in the first place. So if you aren't doing that, you can use it through the tag editor in the AWS console. But yeah, that's where to find them for sure. Yeah, it can be frustrating to not find all the tagged resources. Yeah.
Great, and I'm going to try to squeeze one more in. This one is from Raj. Any advice on SageMaker cost savings?
It's a good question. SageMaker is definitely one of the expensive services right now, right? SageMaker gives you a setup compute instance for machine learning, and every hour that's running, you are paying for it. So my best advice is to just turn it off if you're not using it. But other than that, I don't know that there's a ton you can do. Yeah.
Perfect. And I imagine as all these machine learning AI tools proliferate in AWS, we'll probably have to have another follow-up summit with you, Stephen, to see how this affects.
I would love to answer any questions. Find me on LinkedIn. I'm Stephen Smiley, and I'll answer any extra questions you've got. I see a bunch more pouring in, so reach out to me.
Perfect. Thanks so much, Stephen, for a great presentation. We can see it's very timely for folks, so really appreciate it.